everyone, my name is Andrei, and I like taking pictures. Some of you may ask, what's so special about me taking pictures? I take pictures of the human skin. Some of you, of course, can say, well, that's weird. Well, that's not weird at all. And here, I will try to tell you why. So, I'm a PhD student at Technical University of Munich, and I work on the development of an awesome technique which we call RSOM. And we use this technique to image human skin in biological and medical applications. The first question usually we ask, why skin? Well, did you know that skin is the largest organ of the human body? Also, it has very complex multilayered structure. It consists of many appendages and skin components such as hair, subcutaneous fat, microvasculature, and many more. Also, being such a complex organ, skin is affected by various diseases. Psoriasis, scleroderma, skin cancers, melanoma, you name it. I mean, some of them really deadly. Also, there is evidence that many of the, in the skin you can find at very early stage signs of cardiovascular diseases, diabetes, or metabolic syndromes and others. So that's why it's important to look inside the skin and to see what's really going on. Because so far there is no modality that has done it, and we are sort of the first. That's why we developed RSOM, which stands for raster-scanning optoacoustic mesoscopy system. Raster-scanning optoacoustic mesoscopy system. Anyway, RSOM. The system is based on the optoacoustic effects. The basic idea, in a nutshell, we shine the light inside the tissue, and then what happens? Molecules start to produce the ultrasound. And what we do? Of course, we listen to what they say. And they tell us a lot about themselves. First of all, they tell where they are and how superficial or deep they are. They tell us about how big or small the structures they compose. And moreover, they tell what they are, what kind of molecules they are. So, and using all of this information, we take the pictures of the skin. And at this point, some of you may wonder, so how does my skin look like? And here's the example. What you see here, it's a very, the colors are not the best, but anyway, what you should see, and you see here, is the dense microvascular network. Also in green, you see the smallest capillaries, the smallest vessels in the human body that are used to deliver the nutrition and oxygen to the tissue. All right, so blood. The main component of blood is hemoglobin. Hemoglobin can be with oxygen and without oxygen. And from this, we can extract very important parameters, such as oxygenation of blood, which is used a lot in the medical field. And how do we do that? We use just different colors. We shine the light inside the skin at different colors. Let's say we use one color here, we shine this inside the skin, and then hemoglobin that has no oxygen, it starts to be the loudest. It screams out loud, hey, I'm hemoglobin and I have no oxygen whatsoever. Cool. Well, using different color, we see this picture, which is oxygenated hemoglobin. It has oxygen, and it tells us, well, now look at me, and I have the oxygen, and I'm so cool here. Anyway, but the skin is much more. Skin has many other structures, right? So what else can we see with awesome RSOM? And that's what we see. This melanin. This is the melanin layer. Melanin layer is in the constant. Melanin itself is the pigment, which is in constant battle with the sun. Sun basically tries to kill us all the time, and melanin basically protects us, with our guardian, and it doesn't allow the sun to destroy our body. Also, the color of the hair is basically also melanin. It's what defines the color of the hair. What else we see? Lipids. The winter is coming, it's going to be long, but also awesome, because you can ski, right? But the subcutaneous fat, it keeps insulation, it keeps us warm and nice and happy. Or sebaceous glands, they make our skin also soft and nice to touch. Well, also kind of important, at least to me. For water, we are mostly water, and that's what we see in epidermis over here. That's this technique, RSOM, provides us all of this information at once. So we retrieve morphological information, we also retrieve functional information, and with all of that, our main goal is to move the system, translate the system from the lab into the clinical bed. And that's what we do. We are basically trying, in a very tight collaboration with medical doctors and biologists, to find the biomarkers that are attributed to different diseases, and based on these biomarkers, maybe diagnose diseases earlier or even help to treat them. So that's our main goal, and I hope you enjoy the talk. Be sound and take care of your skin.